Hi everyone, this is Praveen. In this video, we will try to understand the working of vectors in C++. So what are vectors? Vectors are basically dynamic arrays. What it means that when you try to insert an element or remove an element from a vector, the size is automatically handled by the container. Let's look at a definition. It says the vectors are sequence containers representing arrays that can change in size. But unlike arrays, the size can be changed dynamically, with the storage being handled automatically by the container. So let us see how vectors are represented in C++ and what operations we have that can be performed on vectors. To include vectors in your program, you simply call out the vector class using #include vector. To define a vector, the general syntax for defining a vector is vector and then the data type of the vector that you want, and then different vectors. You can define multiple vectors by separating them with commas, v2, v3. These are vector names. So this is the general syntax of a vector. So let's define an integer vector now, vector of int, and let's say v1. Let's now try to perform some basic operations on vectors. But before we do that, we need to insert some elements into the vector. So let's do that first. Let's say we are inserting 6 elements. So v1 dot back and I. So in this loop, we just inserted elements 0, 1, 2, 3, 4, and 5 into the vector. So let's try to move into basic operations, but before doing that, let's try to understand the concept of iterators, and then we can move to all the operations that we can perform on vectors. So iterators, what are iterators? Iterators are simply pointers. They are pointers, and sometimes people call them magic pointers. Iterators helps us to iterate over a container class. The major advantage of using iterators is they provide a common interfaces between all their container classes. What I mean by that is we have different container classes such as vectors is one of them. Then we have maps, hash, and then sets. So all these complex data structures, they are very difficult to handle if you take the most generic approach on them. But however, if you use iterators, they provide you a common interface so that you can traverse or iterate over all of these different types of complex data structures in a very similar manner. Moreover, iterators consist of two public member functions, which is begin and end. As these two member functions, they return a pointer to the beginning and end of a vector. So to understand where exactly they point, let's look at this image below. So we have begin, which points to the 0th element, and we have end, which points beyond the last element. Let's now go back and create a iterator which will help us to iterate over our vector. So to create a iterator, we simply use vector of integer and iterator, which is a function in the container class vector, and we name it as it1. So now it1 is a type integer pointer. So for it1 is equal to v1 dot begin, which is our vector name, it1 not equal to v1 dot end because we do not want to go till end, and then plus plus it1. So if we do a cout and some space and then value at it1, because it's a pointer, uh, we expect this result to be there. Now let's check. Okay, we get the expected results. Along with the begin and end, we also have a constant and reverse begin and end. Constant is generally not used much, but reverse may be helpful sometimes for printing the reverse of the vector. So what reverse begin or technically r begin and reverse end or r end is generally used to set pointers from reverse order in a vector. So our begin will point to the last element and our end will point to the zeroth element. Hence we can use our begin and our end to print the reverse of a vector, which may be of type integer or maybe a string. So it can be very helpful and efficient in terms of printing the reverse of a given vector. But here the if you generally define vector reverse vector, so we have reverse iterators, reverse iterators and it2. But this method is very tedious, so people do not generally use this. Instead they people use auto keyword, which takes some auto and some name of variable, and then say v1 dot begin. So now what happens is, when v1 dot begin is analyzed by the compiler, it says v1, it sees that v1 is a vector, and begin returns to the pointer to the first element. Hence auto will, based on its right hand side evaluation, will give it a data type of iterator, which means now it becomes a iterator, because according to the compiler v1.begin returns a iterative pointer to the vector v1. Hence auto automatically handles all these cases, so we do not need to use the reverse iterator anymore, and it's much simpler to code now. So let's just switch to code Visual Code Studio. And because my dev C++ does not support C++ 11 standard, so just let's just copy the whole code to Visual Studio, and then we'll continue the demo on vectors from Visual Code Studio. So okay, so we are at Visual Code Studio. So now let's print the reverse of the vector using our begin and our end. So first we'll give a space so that we do not club both output, and we can easily say it. So for auto it some variable name, so it will take now our begin. It will now take iterative pointer, which points to reverse of the vector. So it not equal to v1 dot our end, and then plus plus it. We have this, and then we do cout some space and value at it. Now let's see. Okay, we have a mistake here. Now let's see the output of this. We should get the reverse, and there we have the reverse, exactly the reverse. So that's how rn works, and it can be very helpful in scenarios where you need to print the reverse of a string or check for palindromic and questions such as them. Not just strings and palindromic questions, vectors are very powerful. I'll just show you another example where you feel the power of vectors. Let's suppose you have an vector which has elements 1, 1, 2, 2, 3, 3, 3, 5, 6, 9, and maybe 10. So let's suppose that you need to count the number of occurrences of 3 in this vector. So the most generic, where you apply a for loop, that will directly give you O of n time complexity. Whereas if you use vectors, this can really be solved by O of 1 time. So let's see how. So I'll create a vector v and then push all these elements, and then first see how the vector looks like. So let's do that first. So here we have a vector v, and then I pushed all these elements inside it, and then we are printing all the elements. So let's see the output first, so that we are on the right track. Yes, we have all the elements. Now let's suppose you need to count the occurrences of 3. So to count the number of occurrences of 3, we can make use of two functions called as upper bound and lower bound, which takes iterators as inputs and a constant value. So the return of a lower bound, will result in values which is equal to or greater than the constant value. So let's suppose if I pass 3, then it will point or a pointer, return a constant or iterator pointer to the first value that is pointing to 3. Whereas if it is upper bound, it will return the value which is just greater than the constant value, which is just greater than the const value. So if I pass in 3, then the function will return the next value which is just greater than 3. So let's just create two auto iterators and then we'll store upper bound and lower bound values in it. So here we have them of they're imported. So just import this algorithms library so that this error is removed here. So just to print the count of 3, you simply need to do is it2 or I2 minus IT I1. This prints say out until just to, and then let's see the answer that we get. So we have four threes and the answer is 4. So when just one time you just solved the count of 3. That's the beauty of vectors. We along with all these functions, we also have functions such as at or front or back, which simply returns the pointers to the particular value or front or end. So we can simply do see out let's say v dot at, and then you specify a position, so constant size at position. So let's say third element we'll check, and then we'll do an endl, and then also we have out v dot front, and then this will return the pointer to the first element, and we also have cout v dot back, so which returns a pointer to the last element. So all these should return particular values. Along with all these functions, we also have many other functions such as swap or pop back or reserve. So there are many other functions, but let's not dive right into those because those are not commonly used. We generally used all these functions whatever we have just discussed till now. Now let's move to 2D vectors. 2D vectors are very similar to again 2D arrays, but the only difference is a dynamic memory allocation, which is in vectors is already handled by the container class. So let me just move all this into a particular function, and we'll continue using 2D vectors in the main itself. Void vector 1D, I'll just name it 1D, and let me just paste the whole content here. So we have the whole content here. Now let's talk about 2D vectors. So 2D vectors behave in a similar manner as our 1D vector does. So the syntax also remains unchanged, but the slight change that we see that now we have vector inside a vector, which is expected. So now we just created a vector v, which is a vector of vector. So now v becomes a 2D vector. So let's say we have a number of rows is equal to 4, some random values, I'm simply taking them. Let's see, we have a column equal to 5. We have two methods for initializing our 2D vector. The first method follows the generic approach, that is use another vector, create a temporary vector row or any other name, and then insert values into that row, and then at the end of each loop iteration push that whole vector inside the vector or our 2D matrix V. So that is our first method, and let's try to implement first. So equal to 0, I less than rows, I plus plus, and we will simply create a new vector of let's say row. Now what we will do is for j equal to 0, j less than number of columns, and j plus plus. So what we will do is we'll simply insert values. So row dot push back some random values. So let's say modulus 100. And since we do not want zeros, we'll add one to it. So now we added random 5 values in the row, and now let's push back this row vector into the vector v. So v dot push back and then row. Yes, so we have something like this is the vector v. Inside this vector, this is the row vector, and then the outside is our whole vector v. So we, and then we have several instances of row like this at each iteration. So this is how a vector looks like, and so on for many number of rows. So for checking output, let's just see if it is working not or not. So let's I equal to 0, I less than v dot size, because now the size is total number of row iterations. Then I plus plus for int j equal to 0, j less than v of I, that is row dot size, and j plus plus, and see out v of ij, and then some space, and let's put a handle here so that the output is in a proper 2D matrix form. So let's see the output now. Okay, yeah, so we have our expected output. Now let's just see, for simplicity, let's see the output of number of rows, which should be given by v dot size, and number of columns. Let's give a space here, columns, and then this should be given by v of, let's say, 0th row dot size. So this gives the number of columns. So let's see the output of this to check we have proper number of rows and columns. Okay, it's taking some time. Let me run that again. Wonder why that was not producing the output. Yes, so we have 4 rows and 5 columns. Let's discuss the second method now. So the second method, so let's create a vector v1 so that we do not have any problems in terms of the number of copies of vectors. Now the second method is to simply resize. So v1 dot resize, we say that how many rows we want, so number of r, and then we create another vector inside this which will be of integer type, and which will tell that in each row we will store a vector whose size is c. So this means that in each row we'll have a vector, corresponding vector whose size is c. So this creates a 2D matrix. This again results in this, and then the size of each vector in this is c, and so on. Now let's check out the dimension of this. So let's say rows in v1 is v1 row size, and calls in v1. This should v1 of 0 dot size. This should give us the output. We handle here. Let's see the size of vector v1 that we just created. I wonder why it takes time. Let's try it again. Yes, so we created a vector whose again rows in v1 is 4 and 5. So now the method of insertion just changes a bit. Instead of this, we'll just copy first this. Now we do not need to use this row vector now, and instead we do not even need to push back anything. We can simply say v1 of I and j equal to random int of I, and then this does not exist. Why we are doing this and not pushback? Because pushback increases the size. We do not want to increase because we already have mentioned that we want a specific 2D vector of this size. So we do not need to use pushback. Instead, we need to index all the elements. So that's what we are doing with I and j. With each index, we will simply putting in a random value. So let's just see the output of v1 now. We'll copy this loop and let me change v1 v1 and v1. I think this should work. Let's see. Okay, yeah, so we get the expected output. All the functions that we have learned for 1D vectors exactly apply on 2D vectors as well. So let's just conclude the video.